Section 1.7, example 49, evaluating a definite integral using inverse trig function. So evaluate this definite integral. Let's see. So to start this section off, they gave us these three formulas right here. So when we see something that matches either one of these, those are the functions that we're going to end up with. I don't like that they kind of just forced you to just use this. What I want you guys to learn is how it actually happens. So here, when we see the square root of a difference with no outside function, because we have like this versus this one here, this one has that outside function, this one doesn't. So here we're going to use sine or cosine. Sine is a lot easier to use. When we don't have a square root, we have the sum of two values here. We're going to use tangent. And when we have that outside function, both of these squared, and with a minus in the middle, we're going to use secant. So for this first example, it looks like we're going to use sine. So let's take a look at how we could integrate this with sine. So from 0, 1/2, square root of 1 minus x squared over 1 dx. So there's going to be a triangle associated with this. So with this triangle, x's and y's are what I'm primarily going to use. So we're going to call this angle y. And let's see. So we're going to use sine. So we have sine of y. Here we're looking at this value to be out here. So this is going to be our x. We're looking for this value to be over here, 1. So what we have here is sine of y is equal to x over 1. So remember, sine is opposite over hypotenuse. So opposite over hypotenuse. And the way I got that is because we have this. Notice right over here what that value is using our, so we have a squared plus b squared equals c squared. We have x squared plus, well, we'll call this y squared equals 1. So y ends up, I don't like using that one. All right. So x squared plus b squared equals 1. B is equal to the square root of 1 minus x squared, which is what we have right over here. So here we have 1 minus x squared in that value. And with all of that said, we just have to kind of choose all this stuff carefully. Let's start our integration. So we're going to do a substitution. So again, we're substituting sine of y is equal to x. So everywhere we see an x, we're going to plug in sine of y. So let's plug this in. And then we're also going to have to change that integral. So when x is 0, what is y? So we could think of this as y is equal to sine inverse of 0. So sine inverse of 0. Where is sine 0? When is y equal to 0? It's going to be either here or here. It's going to be this one here because that's part of the range. So it's just 0 here. And next, where is sine 1/2? Y is equal to sine inverse of 1/2. So sine inverse of 1/2, when is sine 1/2? So when is sine positive 1/2? Looks like it's going to be right here at pi over 6. All right, so we have that. Everywhere we see an x, we're going to put sine of y. Oh, also I forgot to differentiate. So let's give ourselves a little bit of space. So we're differentiating with respect to x, differentiating with respect to x. All right, so the derivative of sine y is going to be cosine. There we go. So it's going to be cosine y dy. Over here, it's just going to be 1 dx or just dx. So now wherever we see a dx, we're going to plug in cosine y dy. So that we could throw in the numerator over here. Cosine y, in the denominator, we have the square root of 1 minus sine y, and that is squared. Not dx, but dy. All right, things are looking a little bit better. So from 0 to pi over 6, cosine y over the square root of 1 minus sine squared is actually cosine squared. So cosine squared y dy, 0 pi over 6. We have cosine divided by cosine is 1. So we have 1 dy. So integrating that, we have y evaluated from 0 to pi over 6. So that is simply pi over 6 minus 0, pi over 6. So integrating this function from 0 to 1/2 gives us pi over 6. Simple as that. Now, if you have any questions, please feel free to ask. Otherwise, bye.